Hello everyone, today we are continuing our 2D geometry unit on section 3, which is area in the coordinate plane and area of composite shapes. Before we do anything with area in the coordinate plane, we need to remember our distance formula and our Pythagorean theorem. So our distance formula is d is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Then we have our Pythagorean theorem, a squared plus b squared equals c squared. Starting with example 1, we're going to find the area and perimeter for this shape here. And I've already plotted my points and drawn the shape, but I do need to assign these points some labels so that we can identify them. So I'm going to zoom in here and I'm just going to go around like this, A, B, C, D. So I have A at -1, -4. I had B at 2, -2. I had C at -1, -1, and then that leaves D to be -4, -3. Now I'm going to start with the Pythagorean theorem, and I'm going to take that and I'm going to solve for each of my side lengths, because I can't solve for area or perimeter unless I know how long each of these sides are. So starting with AB, I'm going to count my horizontal and vertical distance traveled to create a right triangle to solve for my hypotenuse. So I went over 3 squares and up 2 squares. So I have for AB squared is equal to 2 squared plus 3 squared. That gives me 4 plus 9, or in other words, we have the square root of 13, which means that AB is going to be approximately equal to 3.61. Now I'm going to go across the way and do side CD next, because I'm pretty sure that these sides are congruent. I do know that they are parallel, but I'm going to check the length to make sure that they are congruent. And I'm going to go up first, so that's a horizontal distance of 2, a vertical distance of 3. That means I'd have 2 squared plus 3 squared equals CD. Well, I already know what 2 squared plus 3 squared is equal to, and it's going to be the same format. So I'm going to give myself a little bit of a shortcut here and call this CD is equal to AB, and they're both approximately 3.61. And I am going to mark those as congruent because I do know now that those two sides are congruent. So now we're going to find BC. To find BC, I'm going to check my horizontal distance. I go up 1 square and over 3 squares. So I have for BC squared is equal to 1 squared plus 3 squared. That gives me 1 plus 9, and I need to take the square root of that in order to solve for BC by itself, just to make sure that it's clear. BC squared is still equal to 1 plus 9, and then BC squared we have to undo by taking the square root. So 1 plus 9 is 10, so I'm really taking the square root of 10. That means that BC is approximately equal to 3.16. All right, now we need to check for DA. DA goes down 1 and over 3. So that means that we are again looking at 1 squared plus 3 squared. We already know how that ends, so I can just say that DA is equal to BC, and they're both approximately equal to 3.16. Since those are the same, I'm going to mark those as congruent as well. And I do also know that those are parallel. We could check by finding the slope, and if you do, you're going to find that they have 2 sets of parallel sides. That being said, this is a parallelogram, but it's also another type of shape. This is a rhombus, and because it's a rhombus, our area formula is area is equal to 1/2 P times Q, which is our diagonals. So we need to solve for our diagonals. So in order to do so, I'm going to start with the diagonal that I already know, and that diagonal is right here. It's from C to A. And this is a straight line. They both have the same x value, so I can just count the squares on this one. I have 1, 2, 3. So my distance of CA is 3. And I'm going to say over here, P is equal to CA, which equals 3. Now I need to find my Q. My Q is the diagonal that goes the other direction, although either diagonal could be P or Q. So my Q is going to be the distance between B and D. To find BD, I'm going to have to use the distance formula because I don't have any other way of finding the distance between these 2 points in this given shape. So BD, for the distance formula, that will equal the square root of, for my x's, my bx is 2 minus my dx is -4 squared, plus my by is -2 minus my dy, which is -3, also squared. Now we're going to take that and we're going to simplify it. 2 minus -4, that's really 2 plus 4. So I have, under my square root, I have 6 squared plus -2 minus -3, that's really -2 plus 3, that is just 1. So I have 1 squared. 6 squared is 36, plus 1 squared is just 1. That means that I'm working with the square root of 37. I'm going to take a second to type that into my calculator, the square root of 37. That means that BD is approximately equal to 6.08, and that is what Q will equal as well. All right, so I now have my P, I have my Q, and I know that I have a rhombus with congruent sides. I solved for those side lengths to make sure that they were congruent, but now I also need those for area and perimeter. Now I have all the information that I need for area and perimeter. So I'm going to start with area because I was just working with my P's and Q's. So for area, area is equal to 1/2 P times Q. My P I got to be as 3. My Q was 6.08. And when I multiply all that out, that tells me that my area is approximately equal to 9.12. And that would be units squared because the area is always in terms of square units. Okay, so that's my area. Now I also need to find my perimeter. And my perimeter, I'm going to take the lengths of each side and add them all together. So for my perimeter, I have that CD and AB are both 3.61. So perimeter equals 3.61 plus 3.61 plus my other two sides were 3.16. So 3.16 plus 3.16. When I add all those together, that gives me that my perimeter is equal to 13.54. And again, no units on this one, so you typically would just write the word units. All right, so all of that work was just to find my area and perimeter. I had to find the distance of each side. I had to find the distance of my diagonals, and once I had those pieces, I had enough to solve. Here on the next page, we're going to talk about how you find the area of a composite shape. A composite shape is a figure composed of two or more 2D shapes. To find the area of a composite shape, we're going to follow these steps. 1. Break the shape into smaller known figures. 2. Find the area of each known figure. And then 3. Add the areas together. Or that could be subtract areas if you're taking out a cutout as well. And then whatever your total is, that will be your answer. And then this little note here says, or subtract the area of the cutout, which is what I just mentioned. All right, so example 1, we have find the area of the shape below. I have that this length is 9. I know this whole length is 8, but these sides are congruent. And then down here, I have that this is 1, this is 1, and this is 4. Because I have a shape that I don't know exactly what it is, I'm going to split it into shapes that I do know. So I recognize that I have a rectangle right here. So that is going to be my first shape. So I'm going to draw some dotted lines around my rectangle there. Okay, so there's my rectangle, and I know for the rectangle I need the base and the height. This whole side I can't use, but I do know that 8 divided into 2 is 4, and these are marked as congruent. So each of these things must be 4. If we want to write that down, 8 divided by 2 equals 4. There we go. So now to find the area of my rectangle, so I have area of my rectangle, that is equal to my base, which is 9, times my height, which is 4. So 9 times 4 is what we're looking at, which means the area of my rectangle is equal to 36. So now that I've found my area of this rectangle, I need to address the other piece of my shape. Because I'm not sure if these trapezoids here are exactly the same, I'm going to find the area of this total rectangle, which happens to be the same, at 36, and then I'm going to subtract the area of this cutout because I do know enough about this cutout to find the area of this piece here. So, to start with our cutout, I know for sure that my first base is 4, and then I know down here this piece needs to be 2 less than 9. So 9 minus 2 is 7, so the length of this is 7. I'll add that in. And I know my height from over here has to be 4. So the area of my trapezoid is equal to 1/2 the sum of the bases, so that's 4 plus 7, times the height, which is 4. I'm going to simplify this down. 4 plus 7 is 11. So I have 1/2 times 11 times 4. 11 times 4 is 44, so I have 1/2 times 44. Half of 44 is 22. So that's the area of my cutout trapezoid. So now I need to take that and I need to subtract it from the area of this overall rectangle, which we already found to be 36. So that means that I have 36 minus 22, which is equal to 14. And I'm going to take that 14 and I'm going to add it to the area of my rectangle. So 36 plus 14 equals 50, which means my overall area of the shape is equal to 50, and then these are all in terms of feet, so this is square feet. All right, I will also mention if you did some more figuring here, we would actually be able to figure out that these trapezoids are the same, so you could find the area of this trapezoid and this trapezoid and just add them. That's your other option. Okay, example 2. Find the area of the shaded region below. So I have this triangle here, and then I have a cutout right here, and we need to find the area of this cutout and subtract it from the area of this triangle. So I'm going to start with what I do know, and what I do know is that the triangle has an area of 1/2 times the base, which is 18, times the height, which is 26. Which half of 18 is 9, so I really have 9 times 26, which means that the area of my triangle is equal to 234. Since I know that, I can now move on to getting the area of this cutout and then subtract it from my known area of the triangle. So my cutout is a half a circle, and it shows that my diameter is 9 feet. So if I know the diameter is 9 feet, then I can cut that into 2 and use that as my radius to find the area of this circle. So I have 9 divided by 2 equals 4.5. Now that I found the radius, I can use that to solve for my half circle. So the area of my half circle is going to be equal to 1/2 the area of a circle. So I have 1/2 times my pi times my radius, which is 4.5 squared. I'm going to plug in my calculator, 4.5 squared, and then divide that by 2. That gives me that I have 10.125 pi. Now I'm going to take that and I'm going to multiply it by pi, and I did use the pi button. And when I do that, that gives me that I have an area of 31.81. Now I'm going to take that and I'm going to subtract it from 234. So I have 234 minus 31.81, and that gives me my total area, which equals 202.19, and this is also given as feet, so this is square feet as well. This is where we're going to stop for today. We'll continue with section 4, which covers what happens when we change the dimensions of a shape.